Hello, I welcome you all. The problem reads the 50 kg boy jumps on the 5 kg skateboard with a horizontal velocity of 5 meters per second. Determine the distance as the boy reaches up the inclined plane before momentarily coming to rest. Neglect the skateboard's rolling resistance. This problem is coming from the Engineering Mechanics Dynamics 14th edition by R.C. Hibbeler. And in this particular problem, we are going to apply the principle of conservation of momentum. Remember, we talked about linear impulse and principle of linear impulse and momentum. And the moment the external impulse or the impulse itself is zero or negligible, then what we remain with is the equation that governs the conservation of momentum. And this particular equation is expressed as for a system of particles, so we'll have summation of m sub i v sub I 1 equal to summation of m sub I v sub I 2. Right. So what we have here, so we have a boy, and boy will have some weight here, as well as his normal force. We'll have the skateboard, also that will have some weight, and the normal force. So this is, maybe we say W B. This is the NB. And this is skateboard, like so. This is W skateboard. Right. So here, the velocity of the boy is equal to 5 meters per second, and the velocity of the skateboard at this point is equal to 0. Right. So the velocity of the skateboard, okay, is equal to 0. That's 0 meters per second. Right. So we expect the skateboard to move somewhere here. Okay. Say the skateboard moves somewhere there, like so. We have this guy there. This guy, there we go. Okay, there we go. So at this point, we're going to be looking for our V2. Then we expect the skateboard somewhere there. Then we do have this guy, right? Do have this guy. Okay, and this is our V3. We know to say V3 at this point, V3 at this point is just equal to 0. So this is V3. Temporarily, this is the maximum it goes. Then we expect it to start coming down. This one we need to calculate it, right? Okay. So this one is just going to be equal to, that's our height, maximum point there. It is just equal to S sine 30. right? Okay, so what do we do now? So we are going to use this principle of conservation. So this is the principle of conservation. I mean, this is conservation of momentum. Okay, right. So let's work it out. So this conservation of momentum, do we have? We have mb times b, okay, plus msb bsb, okay, equal to. So this is in the first state. This is in the first state. And then we have again mb plus msb, okay, v2. Because in the second state, will have jumped. I mean, the boy will have jumped on the skateboard, so it will be a single system. Right. So let's replace this with numbers. So we do have 50 by 5 plus plus 5 by 0 equals to 50 plus 5, then v2. So making v2 subject to a formula, to find that, this is just going to be equal to, that's 50 by 5 divided by 55. So this gives us a 4.5 from 5. Right, I'll since this is not the final answer, I've left it like this. Okay, so this is our v2 here. Okay, so found v2. Again, we are saying loading resistance is neglected, so this is 4.5455. So once we found this, we are now on this part. See, we are now on this part. So there is a number of ways we can solve this. We can use kinematics, okay, we can use the conservation of energy, right? Because all the forces that are participating here are all conservative forces. So we have kinetic energy, also have potential energy. Okay, so we are calling this point, right? So let's say using the conservation, using the conservation of energy. Okay, we want to use the conservation of energy to find S. I will say T1. Okay, instead of T1, I'll say T2 plus T2 is equal to T3 plus T3. Okay, where our T is the kinetic energy and our V is equal to Vg plus Ve. So we have gravitational potential energy and elastic potential energy. So Vg is also equal to Wh. So we have Va, this is equal to half K S squared. Okay, where K is the spring constant, mv2 squared plus wh2 plus half ks squared, that's 2, is equal to half m v3 squared plus wh3 plus half k s3 squared. But we know that this is 0 here, this is 0, this is 0, and this is 0 too. And we know that this one here, h, is just equal to s sine 30. Right. So replacing the values there, we'll have the following: half our m here. This m here is this m here is mb plus msb. Okay, like so, right? So this is just going to be equal to 50 plus 5. Then v is what we just calculated, v2 4 5, I mean 5 4 5 4 5 5. This is squared. Okay, now this is just going to be equal to u, this is 50 plus 5, okay, by 9.81, and then by s sine 30. So making s subject to the formula, this is just going to be equal to, so we have half by 55 by 4.5455 squared, okay, divided by 55 by 9.81 sine 30. Okay, so this gives us 2.11. Okay, 0.5 by 55 by 4.5455 squared, okay, divided by 55 by 9.81 by 0.5. Okay, sorry. Okay, what has happened? 0.5. Okay, these can cancel out on both ends. 55 by 4.5455 squared divided by 55 by 9.81, 2.11. All right, I think this is really about it. We have found the displacement or the distance the skateboard travels up the inclined plane before it momentarily comes to rest. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.